At some topics out of section 4.4. Let's talk about how to graph sinusoids. So sinusoids are any function that can be written using a single sine or cosine expression. So there would be things of the form f of theta equals a sine b theta plus c plus d, or f of theta equals a cosine b theta plus c plus d, where a, b, c, and d are all constants. Real constants. So theta is the variable, and notice that in these functions we're only using sine or cosine once. So that's what a sinusoid is. So it's just a sine graph, something that can be represented as a sine graph or a cosine graph. Okay, so let's talk about the parent functions first, the simplest sinusoids that exist. So those would be f of theta equals sine theta, and f of theta equals cosine theta. Now notice I'm using theta as my variable here. I mean, I could use x too. So I mean, I could write f of x equals cos x. I mean, it doesn't matter what I use for the variable, x, theta. I mean, most of the time we'll use theta just to remind ourselves that our variable, that our input is an angle measurement. But I mean, we could just use x. We just got to remember then, oh, hey, in this f of x equals cosine x, that inputting the x, oh, we're actually inputting an angle there. So, but it doesn't matter what letter we use, but just be aware that the book will use theta and x. We'll switch back and forth. Okay, so for the sine graph, I'm just going to draw one cycle of the sine graph. So notice how I plot my points first, then I draw my sine graph, and I usually plot about 5 points, and I make them very, very neat. Notice that I'm plotting maxes, mins, and zeros. So the domain here is negative infinity to infinity, and the range, because I could just keep repeating that pattern then over and over and over again, the range is negative 1 to 1. And the scale that I'm using, each tick mark here on the x-axis counts for pi over 2. So the first tick mark would be pi over 2, the second tick mark would be pi, the third would be 3 pi over 2, I'm sorry, not 3 pi over 3, 3 pi over 2, the last one would be at 2 pi. So there's my basic sine graph. Now what about a cosine graph? Okay, it's going to be the exact same wave that I just drew, but it's going to be shifted pi over 2 to the left, I believe. It'll give us the cosine graph. So it's going to have the same domain and range. Excuse me. And I've got the exact same scaling there. So notice that it's just the same wave, except I'm just like I can shift a sine wave to the left or to the right and match it up with the cosine wave. So they're the exact same graph, but there's just a horizontal translation that can turn one into the other. So basically any graph that we could write, we could represent the equation using sine, the sine function. We could also represent it using the cosine function, except we would just have to shift it one way or the other horizontally. Okay, so those are our parent functions, our basic graphs. Now if we want to look at some more complex functions, we're just going to translate those basic parent functions. So let's look at an example here. Let's take a more complicated sine function. How about 2 sine of, we'll say pi over 2 theta. Okay, so we just have to assess the numbers that we've introduced into the equation, how they're going to affect the parent function, and then we'll just have to sketch a new graph. Well, the 2 out in front, that's the a value, that's the amplitude. So the amplitude here is 2. And this pi over 2, that's the b value, and that's connected to the period of the graph. Now we know that the period of these original ones is 2 pi. A lot of times we'll just use p for period. So it's 2 pi for both the original sine and cosine functions. Okay, so now here the b value is pi over 2. Well, there's a formula that relates this b value to the period, and the formula is the period equals 2 pi over b. So if I wanted to figure out the period of this new function, it would be 2 pi over pi over 2, which is equal to 4. Okay, so I know the amplitude and the period, so now I can sketch my graph. So I'll do a quick cycle here. My period's 4, so I know that I can partition off 4 equally spaces on the x-axis, but I know that if the period's 4, then I'm going to make this fourth tick mark here 4. And then I have to figure out how my scale is going to go to make that work. Well, if I've got 4 tick marks here and the last one's at 4, then it's just going to be scaled by 1s. Now the amplitude is 2, so I'll mark off a 2 and a negative 2 on the y-scale, and I'm not shifting the graph up or down at all, and there's no phase shift or horizontal shift. So now I just have to draw in my sine curve. So that's 1 cycle of the sine graph. Now if I wanted to do more cycles, I could just keep the pattern repeating. So if I went out to 8, I could draw in another cycle. So I can draw as many cycles as I want, but I put all of the effort into drawing the first cycle, and I want to get that super neat and labeled and get everything very neat and organized there. And then if I need to draw more cycles, then I can just kind of keep the pattern going. So the key is getting 1 cycle neatly drawn, and then if I need to sketch more or do a graph over a larger viewing area or window, then I can do that, but I spend all the time and energy into getting 1 cycle. Then I can repeat it if necessary. And so notice the important features here are amplitude, period, shifts, things of that nature. So I've got a nice looking graph there. So now let's try a cosine graph. How about f of theta equals, how about negative 4 cosine of 3 theta. Okay. Now there's a negative 4 out in front. The amplitude, it's actually just the absolute value of that. So the amp here, the amplitude is still just 4. Because amplitude, it's talking about height. So, or rather, half of the total height of the graph. So it's always just a positive value. Now the b value here is 3. So I can go ahead and find the period. Period's going to be 2 pi over 3. I reduce that if I can, but I can't. So, excellent. There's my period, 2 pi over 3. And sometimes it helps to think of these in degrees. So my period here, 2 pi over 3, that's equivalent to 120 degrees. It might help to think of that in degrees when I'm making my scale. So I'll do my sketch here. 0. Mark off the amplitude, so I'll make this a 4. I'll make this a negative 4 down here. Okay, now I'm going to mark off my scale. 2 pi over 3 is the period, so I'm going to put 2 pi over 3 right here at the end. Now I'm just going to draw my graph. Now notice that there's a negative out in front, so that means my graph's going to start down here at 0, negative 4, because the negative reflects the graph over the x-axis. So I'm going to draw in my 5 points. There we are. Now I want to get my my scale perfectly set in here. I know that 2 pi over 3 is the period. That's 120 degrees. So that means that tick mark here in the middle would have to be half of that. Well, half of that would be 60, or pi over 3. Half of that pi over 3 would be pi over 6. And then in between pi over 3 and 2 pi over 3, that's in between 60 and 120 is 90. So this would be, that mark would be at pi over 2. So notice sometimes it's easier to cut up the scale if you know what the period is in degrees, because it's easier to kind of like cut degrees in half and do mental math, at least for me at least. So you might find that helpful. Or some people are just so good with and accustomed to radian measure that we can just do everything in radians. But however you find, whichever method you find useful. So there it is. I've got one cycle graph there. It's looking good. And if I needed to graph more cycles, I could.